I'm gonna briefly talk about our future plan. So in the remaining part of this week, our primary task is to enhance the accuracy and efficiency of our technical solution. So first, we will explore how to optimize our processing workflows during data chunking. Data chunking is a very effective method for handling large scale data by breaking down large data sets into smaller and more manageable pieces. So this approach would not only improve our processing speed, but also enhance the accuracy of our data analysis by isolating and addressing issue within each chunk individually. So that's the main thing that we're gonna do is to have a more precise data chunking. And then we would potentially fine tuning our model. This would also improve the adjusting the parameter of a pre-trained model specifically for our data set, which can significantly improve the model's performance on tasks that are closely aligned with our unique requirements. This method would leverage the learned feature of the model. Also, it will apply it to the new and similar tasks, which will enhance the predictive capabilities without the need for training a model with Scratch. Um, we also are gonna improve our real-time database system, which would allow our application to interact seamlessly with live data streams. We will integrate real-time data with the ChatGPT API, and it will enable real-time analysis and decision-making that are crucial for our operations that would depend on the up-to-time minute data. And lastly, we would improve our answer with image feature to empower our, the ability of our chatbot, and it will make more complex information more accessible and engaging throughout the whole presentation and the use of chatbot. So that's our future plan for this week.
Right. So I'm going to talk about some difficulties that we are when we're using OpenAI, and how we solve this problem. So basically, OpenAI, um, the models that we're using is GPT 3.5 Turbo from from OpenAI. And there is some kind of token limits for embeddings. So there's only 16,000 tokens limit for our embeddings. So any embeddings that are greater than 16,000, it won't work. So we need to find a way to solve this to embed like large amount of data. So first we create a new way to store our data. So first we have web scraped Piazza data from Piazza and stored in a database called Piazza PostDB. And this database is has all the posts from Piazza. And what we do was first we read this data from the database, and then we're going to take chunks. So we're going to chunk these data, and then I'm going to use this get embedding function to vectorize all the chunks, the text chunks, and then store it to a database called text vectors. So in this database, there is two columns. One is the text chunk, and the second column is the corresponding vectors. So we create a new database with the text chunks and the vectors. So this code is just basically convert these text into a vectorized form, the format that's stored in a database. And in our main programs, we're not gonna read the Piazza database. Instead, we read the text vector database, which we create from this script. So first we're gonna read the entire database, which has the text and also the vectors, the corresponding vectors. These parts are reading the database and do some data preprocess. And then after we process this, we are going to, and we can start the conversations. Once we start the conversations, once the student user posts a questions to the chatbot, which is here, it will take the user message and the database vectors, which we just read from, which is read from the vector database to these functions, pass to these functions, compare user question to database vector, which is right here. So we take the questions, users questions, and what we read from the database. Here we're going to call get embeddings for the user questions. We're going to pass user questions to get embedding, which is this function. And we are using this model, X embedding 3 small, which is also from OpenAI, to vectorize users questions, and it will return a vectorized question, and it will store in this variable user question vectors. And in here we are going to do a vector search. So we're gonna use cosine similarities to compare which vectors from the database is similar to the user question vectors. So after this vector search, we are going to find the top 50 text chunks, which is the top 50 most related answers for this question. And then we are going to return this text. And then after we return this text, we are going to do the vectorize again, which is here. And we're going to do the embeddings again, the chatbot. And so the chatbot, the model will respond based on the vectors and the text that we find from this formula. So in other words, we compare the cosine similarities between user questions and the vector database and find out the top 50 similar potential answers from the database. And then we are going to take these top 50 potential text chunks, potential answers, to give it to the chatbot and do the embeddings again. And the chatbot will, based on these top 50 stuff, to answer our questions. So, which can make our chatbot more accurate and also more efficient. It can. So from now, there is no token limits. You can embed as much as you want. They will do the vector search, find the top 50 similar potential answers for you, and the chatbot will, based on these answers to these text chunks, to find out potential answers for the users. So we basically solve the token limits problem for this model. And also here, in order to make the answers more accurate, we will take for example, so we find top 50 text chunks, but it will return top 150. It will return 150 vectors. That is because for example, we find one vectors that is inside of top 50 vectors. We're not going to only take these vectors, these corresponding text chunks. We're going to take this text chunk and the text chunk before this text chunk and the text chunk after this text chunk, which will have, let's say, a more accurate potential answers for the user.
This week, we've been working on adding video link to our chatbot, and we got several videos from YouTube, and we're using YouTube transcript API to get the to get the transcripts of the video. So we have the video ID here. This is from the video link, and we also have our original previous database here storing our embedding, all the embedding data we got from Piazza. So what we're gonna do now is to store the transcripts data into our original database. But before we do that, we first merge all the sentences into trunks of size of 500 characters, because this is for integrating the codes, because this is what we do later for in the embedding part. And the start time for every trunk is the start time of the first sentence in every trunk. So now we got, let me run the code very fast. I printed everything out, and you can see this is the transcript with the start time, and it seems fun. So what we're gonna do later is to use this data for embedding, and we're also gonna put the video in the answer. Yeah, that's what we did this week. Thank you for listening.